So today we're going to be looking at glucose and how it is stored within our cells. So if you're new, welcome. If you like what you're listening to, make sure to subscribe. So we're talking about step 8 on how to lose weight compassionately, and that is to substitute simple carbohydrates for complex carbohydrates. So the idea is that by understanding how the body works, you can make better decisions as to what you eat and all the actions or habits that you have in your daily life. So glucose is loved by all the cells. All the cells can utilize glucose as a fuel source. However, when you have too much glucose, it can be detrimental because it gets converted to fat. It gets stored as within the adipocytes of our body. So let's have a look at the 3 main cells that store glucose after it is ingested. We have the liver cells, the hepatocytes, we have the adipocytes or fat cells, and we have the skeletal muscle cells that also store glycogen. We're also going to have a look at the beta cells and how glucose affects it so that it releases insulin. Okay, so let's draw that. Let's go right into it. And so we're going to draw all the cells. We got the beta cells, and so we'll put beta cell, and they're from the pancreas. Inside the beta cells you will have vesicles, so they are made from membrane, so they're like a little membrane forms a circle. Inside you got your protein, your insulin protein, because it is a peptide hormone. The reason that you can't ingest it is because it's a peptide, it's a protein, so you will digest it and break it down, and that is why people need to inject it. In the membrane of the beta cells you have GLUT2 transporters, so GLUT2. Now GLUT2 stands for glucose transporter number 2, and here these transporters allow for the movement of glucose in and out of the cell dependent on the concentration. So if glucose is high in the extracellular fluid or in the circulation, glucose is going to move into the cell. Now the other cells that store glucose are skeletal muscle. So let's draw skeletal muscle here. Okay, a skeletal muscle at rest, when you're just sitting down, relaxing, there are no glucose transporters on the membrane, so glucose wouldn't be able to penetrate and go into the muscle cells. However, when you exercise, there are transporters that are found underneath the membrane in vesicles called GLUT4 transporters. So glucose 4 transporters. When you exercise, this actually integrate into the membrane. They get inserted into the membrane so that you can uptake glucose into the cells. So which makes sense, because when you're running you want to have fuel available. You want to allow the movement of glucose into the cells. They are also insulin sensitive, so these channels will insert into the membrane in the presence of insulin. The third cell that we're going to talk about are adipocytes, or fat cells, and so we'll draw those here. Adipocytes, and similar to muscle, adipocytes have GLUT4 transporters waiting for insulin to be released so they can migrate to the membrane of the adipocytes. Okay, and finally, the last cell that's responsible for storing glucose is liver cells, or hepatocytes. So we'll draw those here. Can you see it here? Yep. Yep. Okay, hepatocytes have GLUT2 transporters, and they're always present in the membrane. And so these are GLUT2. GLUT2 transporters. Okay, so say you were doing a glucose tolerance test. You will drink some glucose in liquid form. Your blood glucose concentration will increase. Okay, because the concentration in the extracellular fluid in your circulation is going to be higher, glucose is going to move into the beta cells. It's also going to move into the hepatocytes because you don't require insulin for glucose to move into the hepatocytes. So you get a glucose moves in, down its concentration gradient, and it also moves into the beta cells. Okay, now glucose, the cells, the beta cells are going to utilize glucose to generate the fuel source, ATP, that we talked about before. So it's going to go here, ATP, and it's going to do this through glycolysis and through oxidative phosphorylation. Now, the significance of an increase in concentration of ATP is that there are potassium channels that are sensitive to ATP. So on the membrane, there will be a potassium channels which are sensitive to ATP, and what ATP causes is these channels to close. So they close. So potassium can't move from the inside to the outside of the cell as easily. So usually the concentration of potassium is high inside the cells and low outside the cell, so you have a gradient. So if there's a channel or something on the membrane that allows the movement of potassium, it will move down its concentration gradient. The other thing about potassium is that it's a positive charge. Usually, in all cells of our body, there is a voltage across the membrane. So all the cells inside are negative and outside are positive. And if you were to put an electrode inside the cell and outside the cell and measure the potential difference, their voltage, you will find that it's about 70, depending on the cell type, but it's about minus 70 millivolts. Now, because you're stopping positive charge from moving out of the cell, it means that the inside is going to be a little bit more positive than it was if this channel was open. And so your voltage is going to decrease. It's going to depolarize. So it's going to become more like minus 60, minus 50, depending on the number of channels present on the membrane. Now, so this is a change in voltage. So the change in voltage is going to cause the opening of another channel. So there's another channel here, and these are calcium channels. And so it causes these channels to open. Now, as I mentioned before, there's a concentration gradient of calcium from the outside to the inside, and also there's a charge. Potassium is positive, the inside of the cell is negative, so you got an electrochemical gradient pushing calcium into the cell. When calcium goes inside the cell, it increases the concentration inside the cell, and it causes the vesicles to attach to the membrane and release insulin. So you release insulin into the circulation. Okay. Now, what's insulin going to do? Well, it's going to go and bind to the insulin receptors on the muscle cells. Okay, and this is going to cause the insertion of the GLUT4 transporters on the membrane. So these are GLUT4, And so glucose can then enter the muscle cells. This is the same thing that's going to happen to the adipocytes. So you're going to get insulin binding to the insulin receptor, causing the movement of these channels to the membrane of the adipocytes. So you get the GLUT4 transporters inserting into the membrane. GLUT4 transporters. Glucose can then enter the adipocytes so that it can be processed and stored. Okay, so what happens in each of these tissues to glucose? So generally, some of the glucose will be stored as glycogen, so it will go glycogenesis, so the generation of glycogen. So glycogenesis. And you're also going to get an increase in glycolysis. Okay, so that's the breaking down. The same thing that happened in the beta cells, it's going to happen here. You're generating more ATP, and therefore you're also going to generate increase in oxidative phosphorylation. Okay, something different will happen here. So there can also be some lipogenesis happening in muscle, but not very much. The majority will be stored as glycogen. So that's going to lead to glycogen. Okay, you can also store some of the glucose as fat, globules within the muscle, but not very much. So there could be an increase in lipogenesis. Okay. In the fat cells, the main way which glucose is going to be stored is through lipogenesis. So you get an increase when lipogenesis is the generation of fat. So lipogenesis. You can also get an increase in glycolysis. And increase ATP. Also increase oxidative phosphorylation as well, but I won't include it in the diagram there. So increase ATP. Okay, in the liver, this is where most of the glucose will be stored in the form of glycogen, so enough to last you for 4 hours between meals. And so glucose is going to be stored as glycogen through glycogenesis. You're also going to get increased glycolysis, and you may get some lipogenesis, but the main way to store glucose will be through glycogen. Now, however, if you've used up all the storage space or as much of the glycogen as you can store, then it's going to be shunted to be stored as fat. Okay, so you can get a little bit of lipogenesis with the excess glucose. So again, here the excess glucose will be stored in the adipocytes as fat. So that's why it's important not to eat too much glucose, excess glucose. So simple sugars, you tend to eat a lot more than you would if you ate complex carbohydrates. Okay, so having said this, you shouldn't feel hungry. You should eat until you're full. It's just the types of foods that you eat, not not how much that is important. Okay, so the other thing we're going to briefly talk, I'm going to delete this, and we're going to just have a giant hepatocyte, and we're going to look at the mechanisms inside some of the steps in glycolysis, because that's where the variation is between glucose and fructose. Okay, so here is a giant hepatocyte, and we have the GLUT2 transporters embedded within the membrane, so it's actually around the whole cell. Glucose in this case is high. We, for example, may have gone to do a glucose tolerance test, and so our blood glucose level's gone up. We're in the fed state. So glucose comes in to hepatocytes. And what drives the movement of glucose into the cell is that there is a concentration difference. It's high outside the cell and lower inside the cell. So glucose will move down its concentration gradient. This concentration gradient is maintained by phosphorylating glucose. So we go here, so glucose 6-phosphate is generated, and this is catalyzed by the enzyme glucokinase. Glucokinase is regulated by insulin. So in the absence of insulin, this enzyme is not going to be available. Glucose 6-phosphate is then converted to fructose 6-phosphate. Fructose 6-phosphate eventually will be converted to glycerolaldehyde, phosphate. I'm just doing the phosphate like this from now on. It's quicker, takes less time. And glycerolaldehyde 3-phosphate will eventually be converted to pyruvate. Now, one of the steps between these two molecules is performed by an enzyme called phosphofructose kinase 1. The reason I'm including these two enzymes is because they are highly regulated, and they will decide whether glycolysis occurs or not. So all this that we've covered is glycolysis. I have left some steps out. I've only included the most important steps. So this is glycolysis. Pyruvate. Glycolysis is the generation of ATP in the absence of oxygen. It can be activated a lot quicker than oxidative phosphorylation, which is the one that uses oxygen. So within a minute, you're using glycolysis. And you generate 2 ATPs per molecule of glucose. Pyruvate can then enter the mitochondria. So the mitochondria are organelles within the cell. They power, it's like a powerhouse. And they're not as big proportionally as I've drawn them. I've just drawn it so I have enough room to write. But they basically provide a lot of the energy that we use for everyday function. So 30 ATPs per glucose molecules will be generated using oxidative phosphorylation, or the Krebs cycle. So pyruvate can then enter the mitochondria, and it will be converted to acetyl-CoA. acetyl-CoA can then be converted eventually to citrate. Now these are just two of the molecules involved in the Krebs cycle. So let's write that down. So Krebs cycle. And as I mentioned before, this is to generate ATP. So we can do lots of reactions and processes, contract muscle and so on. Citrate can then move out if it's not used in the Krebs cycle. It can be transported out of the mitochondria be converted to acetyl-CoA, then converted to monolyl-CoA, which can then be utilized to generate triglycerides or fatty acid synthesis. So we'll do AleppoGenesis. Okay, so far we've looked how glucose can be utilized to make ATP without oxygen and with oxygen. We've also seen that glucose in excess can be then stored as fat. The other way that glucose can be stored is through glycogen, and that happens from glucose 6-phosphate. You will get GlycoGenesis, and that will lead to glycogen. So this is the main way that glucose will be stored. If there is too much glucose, as I mentioned before, you can go down this pathway and start generating free fatty acids. So with that, I leave you today, and next time we'll look at how fructose fits into this whole metabolism. See ya.
And don't forget to like and subscribe down below.